Good morning, general mathematics students. Today we'll talk about lesson 4.4 and it's about general annuity. Now we start by reciting today's memory verse. It's found in Luke 19 verse 23. It says, "Why then did you not put my money in the bank, and at my coming I might have collected it with interest?" This is one of the lines in the parable of the talents. And your MVSA boosters today is about the parable of 10 minas. Actually, a mina refers to the money equivalent to a laborer's salary for 3 months. Um, History says that the parable of 10 talents, the talents there does not refer to the talents like singing, cooking. These are not the ones it's referred, but the talent is equivalent to the weight of a money, how heavy the money is. Read the parable of 10 minas in Luke 19, verses 11 to 27. And you need to answer this question. Write 2 business lessons that you have learned in the parable. At the end of today's lesson, you'll be able to find the future value and present value of a general annuity. And here's our venture activity. It's a continuation of the loaned house, but this time it's a part 2. Now here's a question. If the loan was paid after 10 years, how much did she pay a month for 10 years? And make an estimate. Which will yield a lesser interest, paying monthly or paying yearly? Now let's review some of the terms. Remember, in the general annuity, it happens when the compounding period is not equal to the payment interval. Example, if it's compounded monthly, but the payment is annually. Or if it's compounded semi-annually, but the payment is monthly. That is a general annuity. And if the payment is done at the end of the interval, we call it a general ordinary annuity. If at the beginning or at the start, we call it the general annuity due. And here are some formulas for future value of general ordinary annuity. Now, what is the difference with the formulas in simple annuity? There is B in here. B stands for the number of months in the payment interval divided by the number of months in the compounding period. So example, if the payment is monthly, then only 1. For if the compounding is annually, then over 12. So our B will be 1 over 12. This is the formula for the present value. And here's the formula for the regular payment. Now, how do we solve an annuity problem? Still in 4 steps. Number 1, determine the given details. Number 2, the type of annuity to be used, because it will determine the formula. Then the last will be substitute the given details in the formula. Let's start. Here's problem number 1. Your dad applied for term life insurance. He got a flexible policy because some payment options include policy payout as soon as a target period is achieved or upon contingency. That's death or accident. Some companies offer insurance products that can be availed only upon death. Because of this better option, your dad decided to avail Insurance A's flagship insurance product. Your dad's contribution at the end of each year is 20,000. That is the periodic payment that earns 6%. That's the rate, compounded monthly. So our N is 12 for 20 years. It's for 20 years. Now, how many months You check first. Let's go first to step number 2. The compounding period is monthly. How many months? That's 12. What? Sorry. Let me first check. While the payment interval is each year, they are not the same, so it's a general annuity. The payment is done at the end of each year, so it's a general ordinary annuity. Now, how many months are there in the payment interval? Each year, right? So 12 months. How about for the compounding? How many months? You only have 1 month. So the value of our B is what? That is going to be, the value of our B is 12 over 1. This over the other. The answer is 12. Now, it's a general ordinary annuity, and we're looking for the future value. So we write the formula for the future value. Okay, RP, our periodic payment is 20,000. That's 1 plus R over N to the power of N times T minus 1 over 1 plus R over N to the power of 12, that's our B, minus 1. Using your calculator, the future value will be 749,120 pesos and 12 centavos. This will be the amount to be paid by your dad after 20 years. The next one. The latest cell phone sells for 5,000 down payment and 900 every end of each quarter for 3 years at the rate of 8% compounded semi-annually. Find the cash equivalent of the cell phone. Now, 5,000 is your down payment, while 900 is your payment, regular payment. That's the periodic payment. At the end of each quarter for 3 years. Remember, you pay at the end of each quarter. And this is compounded semi-annually. At the rate of 8%, compounded semi-annually. So the N is 2 for 3 years. We're looking for the cash equivalent. The cash equivalent is the present value plus your down payment. So let's solve first for the down payment. But first we solve for B. How many months are there in a quarter? That's 3. How many months are there semi-annually? That's 6. So let's go to step number 2. By the way, our B is 3 over 6. That's 0.5. For step number 2, the compounding is semi-annually, while the payment is quarterly. So it's a general annuity. The payment is given at the end of each quarter. So it's a general ordinary annuity. And we're looking for the present value. So let's write its formula. It's going to be PV equals P times 1 minus 1 plus R over N to the power, I forgot the T again. Sorry for that. All over 1 plus R over N to the power of B minus 1. Substituting to that, we have 900 times 1 minus 1 plus r. So r over n. It's the power of negative n times t. All over 1 plus r over n to the power of b, 0.5 minus 1. Using your calculator, the answer will be 9,529.28. This is just the present value of your quarterly payments. But the question is the cash equivalent. So you need to add your 5,000 down payment. The total cash price for that is 14,529 pesos and 28 centavos. If you need to review, you can pause this video and check on your calculators. But if you don't need to, then you can proceed to the next problem. Let's have problem number 3. Find the present value. We're looking for the present value of an annuity due of 10,000. It said it's annuity due, right? Of 10,000 payable quarterly. So quarterly, how many months? 3. For 10 years, that's a time. If money is worth 6%, that's the rate, compounded semi-annually. Our n is 2. And how many years are there? How many months are there in n? That's 6 months. So RB is 3 over 6. That's 0.5. Remember that it's compounded semi-annually and the payment is quarterly. So it's a general annuity. And it's mentioned it's an annuity due. So it's a general annuity due. We're looking for the present value. So in step 3, we write the formula for the present value for the general annuity due. Over R over N. We substitute the given details. We have 10,000 R. What's our R? Over N. R of B minus 1 plus R over N. Using this one, the answer will be 304,230 pesos. You can pause this for a moment and check if your calculator will give the same answer. Let's go to problem number 4. Amy wants to save 100,000. Wants to save. That's a future. This is to save 100,000 for her first year of college. She deposits 3,500. That's the periodic payment at the beginning. Annuity due of each month. That's monthly, so only 1 month. In an account that earns 4%, that's the interest rate per year, compounded semi-annually. N is 2. Then, how many months in a semi-annual? There are 6. So our B is 1 over 6. Will Emmy have enough money to save at the end of 2 years? Our T is 2. Let's check for the future value. If you see the payment is done every month, while the compounding is semi-annual. They are not the same. So we have general annuity, and at the beginning, we have the general annuity due. So let us solve for the future value of a general annuity due. Sorry, the formulas are very long. What if your calculator cannot solve it at once? You can solve this one first, then multiply by the other again. Multiply by this one, then this one also. Let us substitute. 8,500 times 1 plus r over n to the power of nt, 2 times t, minus 1 over r over n times r over n over 1 plus r over n to the power of b, 1/6, plus r over n. Using your calculator, the future value is 87,560.82. You can pause this and check with your calculator. The question is, will Emmy have enough money at the end of 2 years? The answer is no. She will not reach saving 100,000. So what can be a farther solution? Emmy can go for a higher interest rate, or Emmy can increase her deposit so that she will arrive to the 10,000, the 100,000 mark. The next one, your parents are planning to save for the retirement. They target to accumulate 5 million in 10 years. It's 5 million the future value in 10 years. To do this, they want to set aside a portion of their salaries and contribute monthly. Monthly, so one month every month for their retirement funds. How much must they contribute per month if they have a chance to invest in an annuity that earns 5%, that's the interest rate, compounded quarterly? So for how many months are there in a quarter? There are 3 months. So our B is 1/3. Let's have the regular payment for general annuity given the future value. So the formula will be P equals FV times 1 plus R over N to the power of B minus 1 all over 1 plus R over N times NT minus 1. Now, our future value is 5 million. 1 is constant, our rate is 0.05, our N is 4. Raise the power of 1/3 minus 1. All over 1 plus 0.05 over 4 to the power of N, it's 4 times T, 10, minus 1. Using your calculators, the answer will be 32,235.08. So your parents need to contribute monthly 32,235.08 so that for 10 years, so that they can have a possible retirement fund of 5 million. If you need to check this, you can pause for a moment and review the problem. Let's go to the last one. A couple left their son with a 1 million insurance policy. Sana all, 1 million, right? What monthly income would a policy provide for 15 years if the insurance company pays 8% compounded semi-annually. The 1 million is left today, so it is the present value. At 8%, that's the interest rate, compounded semi-annually. 2, and how many months are there in a semi-annual? That's 6. And it will be provided for 15 years at time, and it will be given every month. How many months are there in every month? That's 1. So our B is 1/6. Now remember that your payment and the compounding period are not the same. So it's a general annuity given the present value. So let us solve for that one. P equals PV times 1 plus R over N to the power of B minus 1 over 1 minus 1 plus R over N to the power of negative NT. Here, our principal, the periodic payment, the present value is 1 million times 1 plus R over N to the power of B, that's 1/6 minus 1, all over 1 minus 1 plus 0.08 over 2 times negative 2 times 15. Using your calculator, the son will receive 9,481.53 pesos per month for 15 years. If you need to review this problem, you can pause this video and check if you'll get the same answer. This ends our lesson for lesson 4.4, General Annuity. If you have questions, feel free to message me in Telegram so that I can address to that. Bye-bye.